talk about velocity versus time graphs. And today we got velocity versus time graph of a bear. So this is a bear. You'll see that its speed ranges anywhere from 0 meters per second all the way up to 8 meters per second. And that this is over a course of 16 seconds. So a lot of changes in time, or a lot of changes in speed, I should say, in not a whole lot of time. Now, let's be careful here. We use the word velocity. This is not distance. So it's going to be easy as you're looking at this graph to think of everything in terms of distance, but you got to be smarter than that. Be smarter than the graph and think of these things in terms of velocity. So with that in mind, I'm going to explain what happens in the graph in terms of velocity. The bear starts out at a speed of 2 meters per second. And then it keeps that speed for the first 4 seconds. Then from the time 4 to 8, it's going to slow down. And then from 8 seconds to 12 seconds, it's going to speed back up to 2 meters per second. Then from 12 to 16 seconds, it is going to dramatically increase its speed all the way up to 8 meters per second, at which time we no longer are keeping track of the bear. So maybe he ran away from whoever was measuring his speed. That's what I like to think. I like to think he ran away very, very quickly. Okay, so questions we can ask here are going to be a little bit different, but still fairly similar. So questions to look out for. During what time was the bear? A is going to say accelerating positively. So positive acceleration is just like in the previous problem, what we were looking for with positive velocity. If you see a positive slope, that a slope that kind of looks like this, that's how you know that it is a positive velocity. So for accelerating positively, then we're going to also have a question about accelerating negatively. What time was the bear having a negative slope? We're all going to also ask you a question, what time was he moving the fastest? That's going to be different finding that answer than it was in the displacement versus time graph. Same thing with moving in the slowest. For question E, what time was he stopped? Again, that's going to look different. And then lastly, F is when was the bear at a constant speed? So once again, go ahead and take a moment to answer these questions. In the meanwhile, I'm going to look at my fish again. You ready? Great. Let's talk about these questions. First off, we've got accelerating positively. You would accelerate positively anytime from 8 seconds all the way to 16 seconds. Now, which one had the highest acceleration? That would have been from 12 to 16, because in that same 4-second chunk of time, 12 to 16, there's a lot bigger change in velocity. So highest acceleration goes from 12 to 16. And that would also be just in general, whether that's positive or negative. You're accelerating negatively here from 4 to 8 seconds. That's where we see a negative slope, so that has to be the answer. Now, I said C and D would be different. We can pinpoint the exact time in terms of seconds as to when they were moving the fastest or when they were moving the slowest. For fastest, it's exactly at 16 seconds, because at that time, its velocity is the highest. It has a velocity of 8. That is the fastest speed. For part D, moving the slowest, that would be at 8 seconds. At 8 seconds, it has a velocity of 0. So that's also going to be the answer for E. It stopped at 8 seconds because its velocity was 0. If its velocity is 0, you're not moving, you're stopped. Last one, when is it at a constant speed? So here's where we're looking for a horizontal line. And we see a horizontal line from 0 to 4 seconds. So there's no change in speed. That entire first 4 seconds, it's moving at a speed of 4 meters per second. Another way to think about that is that over those 4 seconds, it's going to cover 8 meters. So on the distance versus time graph, that would look, displacement versus time graph, that would look like a straight line starting at 0, 0, and then going to 4, 8. That would kind of be what that line looks like. So these are questions to expect to see on a velocity versus time graph. I know in class we briefly talked about acceleration versus time, those questions, unfortunately for me, are not going to show up on the test. So it'll just be distance versus time and a couple of velocity versus time. So I hope that helped. I hope you're feeling comfortable with this stuff, and I hope you have a great rest of your day. Thank you for tuning in today. I hope you're hanging in there and staying positive. See you guys next time.